Hey guys, so I had someone send me this picture here and asked if I could go over it. This is from homework. I'm assuming this is homework 1.4. Um, you may have a problem that looks exactly like this, or it may look a little different depending on my math lab because it generates different problems. So let's see if I can get my screen to look the way that I want it to look first. Um, okay, so the question was sent to me, first of all, is which lines are tangent lines? So if you look down here, they already have the answer correct. You have your little green check there, which says you have it correct. Um, but I guess they really didn't understand, which lines were tangent lines because I'm gonna highlight this in yellow. Because if you look, you have a purple line there, then you have a green line there, then you have another purple line there. So you have these three different lines, and it's asking you to graph tangent lines. And then there's a S, graph tangent lines. So plural, more than one. I don't want to delete anything. So more than one. Each one of those lines, those are tangent lines. Um, what it means to be a tangent line is that at that one point or at one particular point on the graph, that line has the same slope as the function at that spot. And that tangent line only shares that one point with that function. And I don't know if there's any way that I can put an image in here. Give me just a moment. Um, you can go on Google, just type in tangent lines. Um, let's see if I can download, save image. Let's see. Okay, so good job. So what I did here is I actually downloaded and saved this picture. I'm gonna come over to the side. So this is a quadratic where I have multiple tangent lines. And I'll use my highlighter. You can see at this point or at this line right there, that tangent line and that function, they share one point in common, okay? And that line, that tangent line, which has a slope of 4/3, actually has the same slope of this quadratic at that point. Okay. Now, what do you know about a quadratic and its slope? The slope is changing. Okay, because if it didn't change, then you would have a straight line. A linear function has one slope. Quadratic, its slope changes. So what happens here, and I'm gonna use my blue highlighter, up here at the top, you have a different tangent line. At that point, the slope of the tangent line is 2/7. Okay, it's because you've moved to a different spot on that graph. The rate of change is different, so that means that your slope is different. So that tangent line is going to look different. So to answer your question, back to where we were at with our homework, all of these that I highlighted in yellow, all of those are tangent lines, um, but they're tangent lines at different spots on the graph. So that's why their slopes look different. Okay, so so that answers that question. Now, I'm assuming that we still had trouble maybe answering the question. So let's see if I can delete. I'll leave that up there for you guys where you can see it. So let's come back over here. So part B is asking me to draw tangent lines to the graph at points whose x coordinates are 0, 1, and 2. So I'm assuming that you really didn't have to find those tangent lines, that you could just kind of look at it, because if you understand what a tangent line looks like, that it just grazes at those points, then you should be able to look at A, B, C, and D and just kind of choose which ones have points there. So how do I know that these are the correct tangent lines? Because you would have to choose, right? So it's telling you at coordinate 0. Well, where is 0 on your x-axis? Right there. right? So when x is 0, how do I graze the graph at that point? Well, it would have to be a horizontal line, right? What about when your x is equal to 1? So where's 1? Here's 1, right? But 1 on the graph is actually up here. So I've got to graze that graph. So that means that I would have that line there, right? And then at x equals 2, 1, 2. So it's here. That means I would have to go up. So that means that that line is up there. And they actually did that one in green as well. So they have a tangent line in green. So you can kind of see how you could just look at it and get the right answer. Well, I'm going to go a little bit beyond, because for chapter 1, you actually need to know how to um, find those lines. Okay, you've got to be able to create an equation of those lines. So we'll actually do that as well. So let's actually jump to part C. So what I'm going to do, if I was to actually have to create an equation for one of those lines, what I would do first is jump to part C. And for part C, it's asking me to find f prime of x, which in short, that means it's asking me to find my derivative. Well, why do I want to find my derivative? If you look in your online textbook or the PowerPoints, any of the notes, what you should find is some words or the phrase instantaneous rate of change. Okay, that's what your derivative tells you, or that's what it finds. It finds your instantaneous rate of change. Well, what is rate of change? Maybe I should write this down. That's my instantaneous rate of change. I'm a math person. I would spell instantaneous wrong, so I didn't attempt it. Okay. The instantaneous rate of change. That rate of change, that is slope, if you remember from prior algebra classes. So short, it's finding your instantaneous slope, which is not the way it's going to be worded. But what that means is that your slope is changing. Your derivative will tell you what your slope is at any particular point, although your slope is changing. It's going to be different. So the way I find my slope for my tangent lines, in short, is by finding the derivative. So how do you find the derivative? The way you find your derivative is finding the limit as h approaches 0 of f of x plus h minus f of x all over h. Okay, so let's come down. Maybe I should, to the right over here, write down what my f of x is. My f of x, just so I can have it in my screen, if I remember correctly, was that 1/2 x squared. So I'm going to use that and substitute that into my function here. So my limit as h approaches 0 is going to be, so f of x plus h, that means that wherever you have an x, you're going to substitute an x plus h. So that's going to be my 1/2 x plus h all squared minus 1/2 x squared all over h. And I don't want to get this overly complicated, so I'm going to leave the 1/2s in there so we don't confuse anybody. But so I'm going to just drop down the limit as h approaches 0. And what I'm going to do is I'm going to square that x plus h. Maybe I should do it in blue so you guys can follow me. So that would leave me with 1/2. And if I square x plus h, that's going to give me x squared plus 2xh plus h squared. If you guys don't believe me, just pause the video, I'll multiply x plus h times x plus h and just check me, make sure I'm correct. Drop down that 1/2 x squared, divide everything by h. And so I want to make a point here. If you've noticed, let's see if I can zoom out just a little bit. So I've did all of this so far, right? This first piece here, that is the calculus. Okay, everything else from here on out is algebra. So I just want to make a note that you guys need to make sure that we work on our algebra skills. If there's anything that we know we're having trouble with in algebra, it's going to, we need to work on it because it will show through in these problems. Um, calculus is algebra. That's it. So we make sure we work on our algebra skills. Okay. So let's finish this. So the limit as h approaches 0, and at this point you've got to remember your distributive property. That's going to give you 1/2 x squared plus 1xh plus 1/2 h squared minus 1/2 x squared all over h. And I'm going to simplify my common terms here. We'll combine like terms, so that 1/2 x squared and negative 1/2 x squared, they cancel one another out, which will leave me with the limit as h approaches 0 of xh plus 1/2 h squared all over h, which means that the limit as h approaches 0, if I divide both parts here by h, that would give me x plus 1/2 h. Okay, so what do I know about limits? So you've got to go back and remember, how do I find the limit? Well, at this point, if I want to actually find the limit as h approaches 0, all you need to do is take this 0 and substitute it wherever you have an h. So what that means is that my derivative is going to be equal to x. How did I get x? I got that by taking that 1/2 and replacing it with 0. 1/2 times 0 gives you 0, which just leaves you with x. And this is your derivative. Because if you look at the top, I told you that your derivative was equal to the limit of f of x plus h minus f of x over h. So once I found that limit, substitute 0 in, right? That tells me what my derivative is for that function. So I told you that gives you your instantaneous rate of change. That's what your derivative gives you. But that's an equation, right? You need a number. So that equation there, that f prime of x equals x, that equation there, that tells you what your slope is at any particular point. So if I wanted to go back to part B, let's see. If I wanted to go back to part B asks me to, no, let's not go to part B just yet. Let's do part D. Part D is asking me to find the slope. When my x value was 0, find my slope when my x value is 1, and find my slope when my x value is 2. Well, this is telling me that f prime of x is equal to x. So whatever is in parentheses here, that is what your slope is equal to. So when my x is 0, my slope is 0. When x is 1, my slope is 1. When x is 2, my slope is 2. So that is part D. So, part D is literally asking me to find the slope. Okay. Part B really didn't ask you to find the equation of the tangent line. But here's what I'm going to do, just because at some point you will. What if I asked you to find the equation of the tangent line when x is equal to 2? Okay, so when x is equal to 2, here's what I do know. I do know that my derivative at that point, my slope at that point is 2. Okay, and I know the equation of the function. I know what f of x is. My f of x is that 1/2 x squared. So I'm going to kind of move out of that screen because I'm kind of extending that problem. I'm doing a little bit more than what I have to do here. So let's find the equation of that tangent line. So what do you need to form an equation of a line? Well, just because I've taught this class a while, I know that they want it in this form. They want you to write the equation of your tangent line in slope-intercept form. So to write it in an equation of a line in slope-intercept form, we need two things. We need the slope of that line, and you need the y-intercept. Well, I'm kind of lucky, okay, because I do know what the slope of my tangent line is going to be when x is equal to 2. We already found that. That's what you found here when you found your derivative and you substituted 2 into that equation. I know that the slope of my tangent line when x equals 2 is going to be equal to 2, okay? And I can make a note here that means your slope is going to be equal to 2. The only other thing I need to find is that y-intercept. Okay. And I can find that really easily because I already have my slope, right? I have an x value, of course, x equals 2. And I can very easily find what my y value is when x is equal to 2. So what I'm going to do is take everything I know, I'm going to substitute it into that equation, right? And the only unknown that I'll be left with is b. So I want to solve for b, which will give me that y-intercept. The only other thing I need to find is that y. So how do you find y? This is where my students in my class had to kind of go back and think. This goes back to your first year algebra class, right? Your y value is your output, not of the tangent line. That is of the actual equation. I want to know what is my y value when x is equal to 2. So what you need to do now is substitute back into the original function. So to find my y value when x is equal to 2, I substitute that 2 into the equation of f of x. That's going to give me 1/2 of 4, which is going to give me 2. So f of 2 is equal to 2. That is the same. That means that that is going to be your y value, right? That's a y out of 4. So take everything that you have and substitute those things into the equation. I know that my y is going to be equal to my m, my x plus b. Now solve for b. This is going to be 2 is equal to 4 plus b. Subtract 4 from both sides. I'm left with a negative 2 is equal to b. So now I know that my y-intercept is negative 2. So the slope of that tangent line when x is equal to 2 is going to be mx plus b would actually be plus a negative 2. So, but I'm just going to say minus 2. And I promise you that if you were to graph this,